Lab guy here. The time has come for me to pull down my amateur television antenna and replace the cable that I used. It's some el-cheapo, what I call laboratory grade cable, 30-foot lengths, 2 of them, with end connectors. My system runs 3 antennas through a single coax using a pair of triplexers at each end of the line. Looking at the antennas from the bottom, the short one on the lower side of the image is the television receive. The long one on the upper side is the television transmit. It operates in the 1.2 megahertz band, 1.2 gigahertz band on 1255 megahertz. The smaller antenna operates in the 75 centimeter ham band, 420 to 450 megahertz, and that is the cable TV channel 58 receive antenna. Not really visible as a straight vertical whip on 2 meters on top of that repurposed antenna foot. The mast that I use to support everything is military surplus, consisting of this aluminum tubing that's perhaps 1.25 inches in diameter, and there's 8 pieces that form the vertical mast. Each one is 4 feet long, giving me an antenna height of 32 feet above grade, and the legs consist of 6 more pieces with a strengthened rim, and they form a tripod using this adapter, and the tripod helps with the erection of the tower. Support of the tower is provided by 3 guy ropes, which I have anchored to the ground with tent pegs. This has proven to be extremely effective over the past couple of years. The big problem, and there's 2, but this is the big one, is this el-cheapo cable. I got this at Anchor Electronics in Santa Clara a couple of years ago, and they had several rolls of these 30 feet long with 2 end connectors pre-installed, and they were $11 each, so I literally bought every one they had. I used a pair of them with a coupler to make my cable to run between the 2 triplexers. This is not great cable for transmitting. It's what I call laboratory grade cable, and it's primarily intended to be used indoors to interconnect high frequency equipment. So the next step is to remove this cable and replace it with some brand new LMR400, I hope I said that number right, and 2 brand new end connectors, which I have yet to install on the cables. I'll be doing that today, and I'll show you how that is done. And then I will be taking down the mast by myself, moving it slightly, re-anchoring the guy ropes, finding new and better places to tie down, and then putting it all back up by myself. I hope with the LM400 installed, I can still lift the whole affair when I get to the last 2 segments when I'm pushing up all by myself, trying to keep it level and lift this monster. It gets kind of heavy. It's awkward for certain. Here's the LMR400 cable that I recently obtained. It's about 70 to 75 feet. I measured it by hand, so who knows. I know that it's more than long enough. The end connectors come apart, as in the lower case, and they come apart for assembly. And you have to strip the insulation back, cut the shield back, and strip the center conductor, all to specific lengths so that they will ultimately fit in the right places inside this left-hand shell. and we'll be doing that shortly. And I'm going to even measure it by eyeballs, just to show you that it's kind of critical, but it's not impossible to do by hand without any resources other than a good sharp knife and a good flat-faced cutter for cutting the coax. Before I start, I want to show you the inside piece of the connector. Outer metal case, inner insulation with a center pin. There's a hole in the center pin in the side for soldering, to get solder inside there. This piece, this wide spot, is hollow. This region within the body, from about here to here, is where the shield will be exposed and cut back a little bit from the end of the center core insulation. The rest of the insulation, outer jacket, will be from here back. The inside of this is threaded, and after you prepare the coax, you twist this on. It will screw itself onto that outer jacket and pull itself on. At that point, the inner shield, the outer shield will be visible through these three holes, and you can solder them there, and you solder the center pin. To finish up, you just screw on the remainder of the body and tighten it with a wrench, and you have a professional installed N connector. N as in Nancy. These I think are good for gigahertz, many gigahertz, up to 2 for certain. And I don't personally know the upper end. I just know they work for my 1255 megahertz transmitter. So let's get started. I've already cut the end of the coax square. It's flat and a clean cut. There's no threads of the outer shield over the center pin or anything like that. Everything is cleanly chopped off. I did that with a pair of brand new snips that I recently purchased for something else. So the first thing we have to do is to remove the outer jacket. To do that, I'm going to use this knife that was recommended by Cody on the Wranglerstar YouTube channel. Wranglerstar. And he has an excellent homesteading channel, and he promotes all kinds of tools if he likes them. Most of the time his promotions are just personal, as this one is for me. I bought this knife based on his recommendation. Check this sucker out. It's a chisel and a knife, and as a joke, when I first received it, I was able to shave with it. So that's a pretty cool tool. That's what we will be using to cut our jacket and shield. But first, let's find our marks. To make my initial cut, I'll just use an X-Acto knife to make the marks. So I'm going to go back to this point. I hope you can see it. The end of the flat end of the coax is very near the end of the wide body of the center pin, the hollow part. And that is where the center conductor ultimately needs to end up. So coming back for the outer shield, which is our first cut, is back here on this shoulder, under here, anywhere in here. So I'll make my mark. And the mark is there. So now I just cut off the outer shield. Very carefully, not to damage the inner wires. This stuff's hard to work with. This is one reason I hate doing connectors, is I believe there's a specific devil that lives inside of wire, and his job is just to make us miserable. If you've ever hooked up your stereo system or a home video system, you know exactly what I'm talking about. And there we go. Garbage. Well, I see shield wires falling off, so we may have to start over. Cut too deep. The knife's too sharp, if you can believe that. I believe there's enough left on that. I think we're good to go. Okay. We're good to go. So, next measurement from that shoulder is up to where I cut off everything behind the center pin, so leaving some room for the internal insulator. I'll make a mark. This will be fun. On this one, I want to just remove outer shield and foil and the wires. I'll bend all that back. Isn't that interesting? What was our mark? Had to be right there. There it is. All right, we're down to center to the center insulator. Now, yeah, that's fine. That's very good. And so the next cut will go somewhere right in here. Alrighty. This knife is kind of scary. It's still so brand new and sharp, but I don't need to go to the doctor today. Just really not in the mood for stitches. Softened it up a little. Get in there with the wire strippers. That looks good. We'll clean up. Oh. Very nice. So next, I get to put all my wire back forward and trim it back to the shield. So I'll use scissors. Okay, now we're going to be twisting this way. Turn my soldering iron on. And that's what that looks like before we solder it. We're not going to solder anything until we make sure we're not shorting out. And we're not. and we're connected to the inside, to the outer shield on the inside there. So that's all good.